Okay, let's talk about money. Here's the deal. What we're going to look at next is called the compound interest formula. Depending where you've done your math before, you may have seen it before, or it might be brand new. I'm going to teach it like it's brand new. Here it comes. And this is actually how interest is figured with investments, with bank accounts, with all that sort of stuff. So it looks like this. This is the equation you need to know. The A here represents how much money you end with. The P is how much money you start with. That's called the principal investment. 1 is just a 1. R is your interest rate as a decimal. Now, interest rates are typically given as percents. It's up to you to move the decimal over 2 spots, turn it into a decimal. So 20% is really 0.2. N is how many times your interest is compounded per year. And this varies from case to case. Even with some banks, they'll do interest every month. Some banks will do interest only twice a year. And it makes a little difference in what your ending amount is. And then T is always measured in years, the number of years for something to occur. So let's put this into practice. Here we go. Question 1, what's the value of $100 if you invested at 2.3% simple interest for a year? Simple interest just means there's no compounding. So you're getting your interest just one time a year. So when you see that, it means that your N is just one compounding per year. Okay, let's put in the numbers and see what happens. So I don't know how much money I end with. I do know how much money I started with. The interest rate as a decimal is going to be 0.023. 1 compounding per year for 1 year. Noticing that everything over here is just numbers, you can just throw this now straight into your calculator, and we'll round to the nearest cent since we're talking about money. Now I'm going to pull up my handheld calculator here. So we've got $100, 1 plus 0.023. Now, dividing by 1 doesn't change anything, so I'm not even going to write it. And then that's to the power of 1 times 1. Oh, we don't even need to round it. So after a year, you have ended up with $102.30. Now, here's the thing. I hope that makes sense. Let's just think for a minute. 2.3% of 100. Well, that's just $2. That's $2.30. So add that on to the $100 you already had. That's where you now have $102.30. There you go. Now, the second question I'm going to ask is, okay, well, what if we take this same investment, but instead of doing it for 1 year, let's this time do it for 2 years. Nothing else is going to change. So we're still starting with $100, still investing at 2.3% interest, compounded once a year, but this time it's for 2 years. I hope right away you can see that it's going to be more money, right? Because we're compounding that interest for 2 consecutive years. But it's also not going to be $104.60. You're not just going to add another $2.30 onto this. That's because 2.3% of 100 was $2.30. 2.3% of this number is a little bit bigger than that. Not much, but a little bit bigger than that. That's why we call it compounding interest. It builds on itself. Okay, so let's throw this in the calculator. Actually, it's the same calculation. I just need to change the 1 to a 2 up here. So $104.65 is where we'll round that. $104.65. So with this formula, it really is all just about knowing which numbers to put where and making sure that your answer seems somewhat reasonable. So after the course of 2 years, just by doing nothing, you've earned almost an extra $5. That's how interest works. Have you ever heard that expression, it takes money to make money? That's what they're talking about. All right, let's go again. Just some practice using this formula. Okay, so same amount, same interest rate. Ooh, but quarterly compounding this time. Okay, so 1 year, quarterly compounding. Now, quarterly means that instead of doing interest calculations once a year, we're actually going to do the interest calculations 4 times a year. So when you see quarterly, it means this. Now let's take a look at how that shows up in the formula. So you start with your $100, you have your interest rate, but notice you're not getting the whole interest rate every time. We're taking that 2.3% and splitting it into 4 parts. Now, there's a trade-off. We're also then going to be compounding the interest more often. So you get a smaller amount each compounding, but there's more compoundings. Let's take a look at how it works out in the end. So 1 plus r over n to the nt, still doing this just for 1 year. So in the calculator, let's just type this in like it looks. So 100 times 1 plus 0.023, come on, plus 0.023 divided by 4. Now, when you are typing this in, make sure that your exponent has the 4 times 1 up in there. So if it's something like 4 times 1, I say just do it in your head and type the 4. I don't want you to accidentally not include the multiplication in your exponent and get the wrong answers. Okay, let's see where we end up. So $102, and this would round to 32 cents. $102.32. Here's the thing about compounding. I want you to compare the red answer here to the red answer here. Just changing how often the interest was calculated from 1 time a year to 4 times a year earned us an extra 2 cents. And that's not an error, that's not a mistake. That is actually how it works. So if you have a choice, which in reality you usually don't, but choose more compoundings if you can, because it doesn't get you a lot more money, but it does get you a little more money. Okay, there's a second calculation here. What if we go from quarterly compounding to monthly compounding? Now, when you see monthly, that means you're doing this 12 times a year. So let's take a look at how that all comes together. So the amount we end with is our $100, 1 plus 0.023 over 12 this time to the 12 times 1. So dividing that interest rate among 12 months, but then compounding it 12 times. I'm just going to come back here and change my 4 to a 12 and change this 4 to a 12. Let's see what we get. So $102, and if we're rounding, which we are, it's still $102.32. Okay, so in this case, going from 4 compoundings to 12 compoundings didn't actually get us any more money. Now, if you look at the big long decimals, yeah, the big long decimals are a little different. The second one is a little bigger, but not bigger enough to change the amount of the investment once we round to the nearest cent. So it's the deal. If you know where to put the numbers into this formula, you're going to be doing just fine. Let's take a look at these next examples, and then we'll wrap things up. Just some vocabulary, first of all. These are the different types of compoundings you may see. So semi-annually, twice a year, quarterly, monthly, weekly. Oh, this should say, of course, 52 compoundings a year. And then daily would be 365. In reality, I think most like typical banks do a semi-annual or quarterly compounding. These are rarer. Here we go. Next up, how long should this money be invested? Compounded quarterly to mature to $5,000. To mature means that your investment grows. So that's actually the ending amount. So if I want to end with 5,000 and start with 3,500 at 4.5% interest compounded quarterly, the question is, How long should that be? How many years? What does the t need to be? Now notice, we don't know what the t is. It's up there in the exponent. We're going to need to do some solving. So here's my advice. If this comes out relatively nicely, let's turn this into a single number. So how much is 1 plus 0.045 divided by 4? Okay, 1.01125. So I'm going to do a little rewrite here. Equals 3,500 times 1 point, I've already forgotten what it was, 0.1125. 0.1125 to the 4t. This is just an exponential equation. You know how to solve exponential equations. Get the exponential part by itself. So we're going to divide by 3,500. 5,000 divided by 3,500. Doesn't come out nicely, but as a fraction, it's just 10 over 7. So 10 over 7 is 1.01125 to the 4t. Switch to your log form. And tell you what, just because I'm out of space, I'm going to move things over and come over here. So log base 101125 of 10 over 7 equals 14. So this is just a number. I mean, it's probably not a pretty decimal number. It's just a number. So divide by 4 to finish off. T is this log divided by 4. Let's see how many years that is. So once again, I'm going to pull my calculator back up. Choose my log base, 1.01125 of 10 divided by 7. So this is just the log, and then I want to divide that by 4. It's going to take about 8 years, 7.97 years. So be a little bit impressed with this because, again, this is the way that the calculation actually works. If you are able to find an investment that pays 4.5% interest compounded quarterly, and if you start with $3,500 and just let it sit there, after 8 years, you're going to have $5,000 in that account because that money just keeps getting more interest each year and each year and each year. It builds on itself. That's why we call it compounding. So quick recap here of what we did. Put in what you know so that we can then solve for what we don't. This was an exponential equation, so isolate the exponential, switch to log form, and then divide to finish it out. Okay, let's go one more time. I'd like you to try this one and then unpause when you're ready to check things, or if you're feeling stuck. All right, let's get to it. Okay, now to double means that I don't really care how much I started with. I don't really care how much I ended with. I just want it to be twice as much. So you can pick how much money you want to start and end with. How about we start with 100 and end with 200? That's doubling. There you go. So if I want to end with 200, and it turns out if you pick 1,000 and 2,000, or if you pick $1 and $2, you're going to end up with the same result in the end. So end result equals starting result times 1 plus, we don't know the interest rate, but it's semi-annual compounding for 20 years. So the variable this time is the R. That's the thing we don't know. Okay, let's do a little simplification. Divide the 100 over. So 2 equals 1 plus R over 2, and 2 times 20 is 40 to the 40th power. Okay, let's solve. This time, because there's no variable up here, we don't need to use any logs. Instead, let's just do a root, a 40th root. So the 40th root of 2, and if we do a 40th root over here, it's going to be 1 plus R over 2 we're left with. Now, 40th root of 2 is a big old long decimal that I don't want to mess with right now. I'm just going to leave it written as 40th root of 2. To get the r by itself, let's subtract 1. So 40th root of 2 minus 1 is r over 2. And then multiply both sides by 2 to get the r by itself. Again, just because I'm out of space, let's finish this up. So the r is 2 times the 40th root of 2 minus 1. Let's see what this turns out to be. Now on the TI calculators, if you want a 40th root, you need to type it like this. In your math menu, you see you got this one, this number 5, the x root. That's going to let you choose what root you want. And for the minus 1, notice that where your cursor is matters. Make sure you're not under the square root, or the 40th root rather. I want to be outside of it. Put the minus 1 on the back. Enter it out. Now this is my interest rate as a decimal. So to turn it into a percent, move it over 2 spots. 3.4959 would round to a 3.5% interest rate. So R equals 3.5%. Now, let's make sure this makes some sense. 20 years, that's a long time. Now, doubling, okay, so we chose 200 and 100, but notice, because you do this division right away, it doesn't matter what numbers you start with. You're going to end up with a 2 here, and then the other stuff on the other side every time. We then did a 40th root because of the semiannual compounding. Okay, and then subtracted the 1 times 2. Process looks good. Now, be a little bit impressed by this. If you want your money to double, which is really a 100% increase, that can happen if it increases only 3.5% each year over those 20 years. One of the most fascinating things in all of mathematics is exponential growth, and you're seeing it in action here. A small percentage increase over time can lead to big changes over time. So if you remember one thing from this lesson, one thing, it's that you should start investing early. You should start your retirement accounts as soon as you are able to put money into them. Because the longer it grows, even if the interest rates are low, it's going to be a big, big amount over time.